Before we begin, we just want to thank you all for attending this session. So we hope you're all staying safe wherever you are during these uncertain times because of the ongoing pandemic. We are glad you could make it to this virtual session. All right, let's get started. So I'm Sumant Venkata Subaya. I have Chingbo who co-presenting with me here. So we are both part of Intuit. For some of you who may not know what Intuit does or what the company is all about, so we are the company behind TurboTax, the most widely used income tax preparation software in the US. So Intuit is also the parent company of QuickBooks, the most widely used accounting software geared mainly towards small businesses and small and medium-sized businesses, accountants, and individuals. So both me and Chingbo are part of the Intuit AI services team. Our primary mission is to build scalable AI services so that we could accelerate the adoption of AI across Intuit's products and services and help Intuit become an AI-driven expert platform. So, here's the agenda. So we plan to cover quite a few things. So we have structured the talk in such a way that we'll go with the high level overview to begin with, and then dive deep into the internals. So most importantly, this being the Spark and AI Summit, so we will go over in depth as to how we are leveraging Apache Spark to monitor our in production ML models. So first, let's get started with machine learning at Intuit. So some of the briefly machine learning use cases at Intuit. So at TurboTax, as I mentioned earlier, so it is the most widely used tax filing software in the US. Our customers have a diverse background, and we understand each of our customers' tax filing situation is different. So we want to ensure the tax filing experience is completely personalized, and we use a lot of machine learning models to personalize this tax filing experience. Also, security risk and fraud. So, well, Intuit being in the financial services industry, as you can imagine, we deal with a lot of uh, highly sensitive data. So as it turns out, there are a lot of bad actors out there as well who are trying to commit fraud. So we heavily rely on machine learning models to keep these bad actors out of our systems and also to ensure our customer data is safe and secure. So we also have a lot of other ML use cases. I'll not get into the details of each one of these, but we have just for starters, we have credit card recommendations, we have small businesses, cash flow forecasting, we use machine learning for image recognition, text extraction. So one of the some of the features in our services is customers can take a picture and upload the receipts. In the backend, we have to extract information from these receipts and forms, the tax forms, so that information can seamlessly be passed in the backend. It's really exciting to see how machine learning is transforming our customer experience overall. All right, so let's talk a bit about challenges in monitoring the production machine learning models. So first of all, why do we even need to monitor ML models once they're deployed in production? Well, for starters, the input data distribution can change over a period of time, and hence the accuracy of the machine learning models will change with the change in the input data as well. So we should monitor all the models in production as much as possible. And so just to give you a brief sense of ML landscape at Intuit, so it's pretty diverse. So there are a lot of data science teams, as you can imagine, and each having its own standards and processes. So we are in fact are in the process of standardizing the entire model development lifecycle as we speak. But the current state is it's pretty diverse. The models are deployed across in a variety of ways. Some of them are batch models, some of them are online. The models are deployed in Kubernetes, EC2, just to name a few. Like, also, all these leads to a lot of fragmentation, a lot of diversity in the corresponding underlying data as well. The model inputs, the labels, and the prediction data itself. So data is scattered all across various different locations. For example, S3, Vertica, Hive, you name it, right? And also the file formats of these data varies a lot. The data can be in Parquet, can be in JSON, Avro, uh, uh, tabular form, and also there is this encryption. So because we Intuit deals with a lot of highly sensitive data, so we do encrypt most of our highly sensitive data. Like sometimes the entire data set might be encrypted, or in some cases, some certain fields within the data sets might be encrypted. And in case of highly sensitive data, both the outer data set as well as some of the internal columns might be encrypted. So this just shows how diverse the data is. And also the labels uh, are delayed. Sometimes it can take up to a few days to a few weeks for us to get the labels. Another challenge is the data quality. So most of the ML data is not clean. A lot of cleansing and transformation needs to happen before any of this data could be used effectively for machine learning purposes and for monitoring in turn. And lastly, the scale at which Intuit works, there are millions of customers, millions of data points collected every single day, and the size scales to several terabytes, and it's really hard to process all this data without a distributed framework. So, because of all these challenges, so we when we first encountered how do we monitor all these models, so uh, as expected, because there is a lot of diversity, a number of Intuit teams had built all these point solutions to monitor their machine learning models. So this led to both parallel efforts as well as the resulting code could not be reused, and it was not scalable in some cases as well. So to address all these issues, so our team, we went ahead and built this model monitoring service with the sole purpose of being able to continuously monitor the in production models for data drift and model decay over a period of time. So MMS, as we call it internally, enables data scientists and or model owners to configure their monitoring pipelines with a variety of model inputs, labels, and predictions completely in a configurable way so that they don't have to write any code to use some of the built-in components of MMS. MMS also provides a default metrics library, which could be used by the different data science or the data scientists or the model owners to compute a variety of metrics. And we have a suite of library which is extensible, which could be uh, contributed back to by the teams if they find some metrics are not already present or implemented. So there is also an API using which these metrics could be extended. So MMS provides a total abstraction for model owners from the underlying processing infrastructure. And we plan to open source soon. So the core components of MMS is built using Scala and Spark. And we plan to open source MMS soon. All right, so let's get a quick understanding of how MMS leverages Spark. So if you're familiar with Spark, this is a no-brainer, given all the challenges that we discussed in one of the prior slides. So Spark has native support to read a wide variety of file formats, including Parquet, JSON, CSV, and so on. So we use Spark to infer the schema of the generic data sources. Uh, And also we use Spark SQL, which provides a clear query interface for any structured data format. So to address scalability, as it turns out, Spark is highly scalable. So just for illustrative purposes, we've just put a table here which shows the scale of some of our sample data sets. This in no way compares to some of the production data sets that we have, but just for illustrative purposes. So if we were to run the processing jobs in an EMR instance, let's say, for example, M5 X large nodes, we could compute thousands of metrics for a variety of data sets, which has like millions and billions of rows with thousands of columns in reasonable times. And we could easily scale out or scale down these EMR nodes to compute to have these computed within our given SLAs. All right. So I now hope you have an understanding, a brief understanding of what MMS is. But let's do a deep dive of the internals of it, and Chingo will walk you through the internals. Thank you.
Okay, thanks, Sumant, for the introduction, brief introduction about what MMS is and what the challenges Intuit AI is facing to monitor in production models. So next, I will dive deep into the architecture of the model monitoring service. To start with, the customer of our service is actually can be a data scientist, can be a machine learning engineer, or can be a data analyst. So in that case, I think the level of their coding skills ranges a lot. So that's why when we start like design the system, we wanted to be starting from a point that the user can only use like a config and then using API to use the system. So basically how the user uses is the user interacted with our API layer, and then it will create a workspace of the model monitoring service. And the different pipelines in the workspace will take the different input and then also generate the metrics, which is the output, and then store it. So there's no coding required if you only use like existing metrics or segmentation logic. I will explain what the segmentation and the metrics means in the later part. And also, if you're an advanced user of the system, so you can use our standard programming APIs to create your customized metrics and the segmentation logic. And then whatever you created there can be also seamlessly used in the system. So model monitoring service consists of, the workspace consists of two types of a pipeline. First one is called the data pipeline, and then the second one is called the metric pipelines. So in the later part, we will dive deep into each of them and see what they are and how do you use them. So before you use the system, we ask this user to basically write a config file to register your model. So you can see here, this is an example of what the user have for to register the one model in the system. So if you take a look at it, it contains some model metadata. For example, like the model's name, model's version, which business unit you come from, and also some additional like tags, all these different things. And also it can contain some optional field, for example, predictive value field. This is one configuration to tell the system which field in your data frame contains your predictive value. And also the actual value field, it contains your label, right? So, but all these fields are optional ones. So when user provide a config like this, the model monitoring service system will recognize each of the field and then register your model. And then after that, model monitoring service system basically will create the two types of pipeline. One is called the data pipeline, and another one is called the metric pipeline. I think Sumant previously mentioned, one of the problems we see is that the data, in order to monitor in production model, the data can come from different data sources and can like varies a lot from different data ranges. So one of the problems when we build the system and trying to survey existing solutions, we find out there's no unified way to both allow you to integrate different multiple data sources and also compute the metrics based on it. That's why we introduced the first pipeline called the data pipeline. So the functionality of the data pipeline is basically trying to load multiple data sources from different storages and in different formats, and it can come from different date ranges. For example, you can load today's label, but then you load like a 30 days ago's prediction result. In that case, you can join them, integrate them, and then calculate your accuracy, precision. Let's say it's a binary classification problem for this model. And then you can, in order to integrate the data sources, so we provide an easy way for them to specify the logic, how to integrate all these different data sources. That's why we're using Spark SQL, because SQL is a very widely used language in pretty much like many different people. And then the result of the integration SQL will be standardized and into a standard data format, and then store them in storage. So the standard data format allows that any output of the data pipeline will have the same schema. In that case, we can provide a standard API for user to how to specify, how to calculate the metrics. So in that case, all the metrics can be reused for any model. And the second pipeline is called the metric pipeline. So the metric pipeline is basically generate those metrics you need to monitor and then store them. So the metric pipeline can load from two different data sources. First one is the output of the data pipeline, which is essentially the integration result of your multiple input data sources. And then it can also load from the output of other metric pipeline, which means it can generate metrics based on previous generated metrics. So the metric pipeline also support a metric dependency. So you can generate the metrics with based on the other metrics within the same execution context. And also it can generate metrics from previous executions of other or maybe the same metric pipeline. So for besides, in addition to metrics, we also support segmentation logic. So that allows you splitting a global data set into multiple segments, and all the metrics used in the global data set can be reused in the segment. So you do not need to write any new code. And we also provide this API to write a customized metrics and the segmentation. Okay, so let's first talk about the architecture of the data pipeline, how data pipeline works. So as you can see in this figure, it's basically, it uses the user provided configs, trying to create a different data sources here. So for example, we have different data sources in S3, and then each of them will load one data set from the S3, and then user can specify the SQL statement, and then we will integrate all these data source, and then standardize them into a standard schema, what we call the relational event. The naming for that one is basically saying the data have certain internal relation between them after you integrate them. And then we store this standard data into either HDFS or S3. So from the user's perspective, how can they write a data pipeline? So as I mentioned, there's no coding required, only configs. So what they need to write here in the config is basically a bunch of sources and also this integration SQL. So the first data source we listed here is actually representing the model's input and output data. So as you can see here, they need to provide the source type. In this case, it's a S3 data, let's say, and also the file format is a JSON. And then besides that, they can provide a data path containing the date as a partition. And also, you also need to require to give a name for this source. So in the later part in your SQL, you can use this name to refer to this source. So as also you can see here for the model input and output, it also has a special field called a date range. So this is saying basically I need to load the 1 day ago's model input and output data. So this is a way to join, to integrate the data sources from multiple data ranges. So in the second data source is, let's suppose that's your label. So it's your newly collected label from today. So previously we loaded 1 day ago's model input and output. We also load the labels collected by today. as well as some additional data, dimensional data, which is not a part of your model's input or output, but can be essential to analyze your model's performance. So in the final part is the integration cycle. So this cycle is basically we use the entity ID, this field, from all these three sources, and then join them. And from the model's input output source, we take out its output. Let's say one field is called output, and which is a Boolean value. And from the labels, this source, we take another Boolean value. Let's say that's the label. And also from the dimensional data, we have an integer field called account age, which is the age of the account. Let's suppose that's the field we need to analyze the data. And then after we join, the result of this integration cycle will be standardized and stored in the storage. And then let's take a look at in the next step, what the metric pipeline will look like. So the metric pipeline, well, essentially we can have multiple metric pipeline. They can load from the relational event, which is the output of the data pipeline, can also load from previous result of other metric pipeline, which is called a monitoring event in this case. So basically can load from two of these two types of data sources, and then it can go to the metrics need to be monitored through the configs user provided, and then register all these metrics need to be monitored and then store them. And for each of the metric pipeline, so basically it looks like this. So from either of the two data types we load, we actually generate this purple figure here. The purple shape here is basically to generate a view based on the data structure. So the view is more user-friendly, which is used in the API. So you can write your own metrics. And each of the orange boxes here is actually workflow. And each of the module in the workflow can be either a metric module, which is to generate some metrics to be monitored, and also can be a segmentation module. So as you can see here, it's in a sequential fashion, which means the workflow will be executed in sequentially. And this ensures any metrics get generated from previous module can be seen from the later modules. So this ensures the metrics dependency within the same workflow can be resolved. So besides the metrics, you can see another one is a segmentation module, which is the middle orange box here, leads to different branches. So this one actually separate the relational event, the output of your model, into different segments. And each of them will have the same data structure. So that's why you can reuse all your metrics in your global data set, also in each of the segments. So let's give an example what the user need to write for a metric pipeline. So as you can see here, they can define this pipeline, which to specify a source. So in this case, it's basically saying I need to load from the latest result from the data pipeline, which is a model event source. And then in the next step, so they can define a workflow, which it contains multiple modules. In the first module, in this case, we're actually generating a metric called a confusion matrix for a binary classification problem. So, and besides the module type equals to metric, which defines this is a metric module, and also the class name to define where is the logic for this metric, it can also allow the user to further configure this. It's basically in this config field of this module. So as you can see here, user can provide a SQL-like condition to tell the system what is a true positive example and what is a false positive example. In our previous example, we see that we take out the Boolean value of the prediction value and also the Boolean value of the labels. And then, so as you can see here, if it's a true positive, the prediction value should equals to true, and the label should also equals to true, something like that. So in the second module, we calculate the accuracy after this confusion matrix. So as you can see, there's no configuration need to be set up here. The reason is that it can also take advantage of the metric dependency. So basically, this module will be looking for the result of the confusion matrix, and then automatically get all this count, all these entries in the matrix, and then compute the accuracy for you. So this saves you a lot of time because you do not need to recalculate all this count in the confusion matrix in order to generate the accuracy. In the third module, we listed here as a segmentation. So this segmentation logic is based on a numerical field, which is the account age. The account age field we extracted from our dimensional data. So we further split our data set into 6 different ranges, 6 different buckets according to the account age. For example, it can be account age less than 1, and also between 1 to 3, and all the way to any account age having a value greater than 9. And then inside this module, you can define a sub workflow, which specify, okay, what are the metrics you need to generate for each of the segment. So as you can see, what we can do here is basically copy paste all the confusion matrix definition, the configuration, and the accuracy configuration directly here. So they have the exactly same configuration. In that case, we can generate confusion matrix and accuracy for each of the segment again. So you do not need to rewrite your code or anything. Basically, it can be reused. Okay, I think that covers all the content we want to introduce today. Thank you very much for attending the session. And now we are open to questions.